In Module 8, we're going to start talking about vectors and polar coordinates, and we're going to start with vectors. So we have to define quite a few terms when we talk about vectors, and one of those terms is called a scalar. So a scalar is a quantity that can be measured using a single real number. So for example, temperature and length are scalars because temperature can be represented by like 60 and I can have a length of 4. So a scalar is just going to be a number. Now a vector itself is a quantity with both magnitude and direction. So magnitude is a number, so it's got a size. The direction tells us where it's going. So for example, force and velocity are both types of vectors because not only do they have a number, but they have a direction. Velocity can be negative, so can force. They have directions associated with them. So there is a difference between a vector and a scalar. So next we're going to define a unit vector. So a unit vector is just a vector with a magnitude, or also called a length, of 1. So it specifically has a length of 1. And there are two unit vectors that we're typically going to see, and those are I and j. So when we talk about the unit vector I, that is, so I, it is the unit vector along the x-axis, and j is the unit vector along the y-axis. Now when we are trying to denote we're talking about a vector, we can either bold the letter, so if I can bold I and j, or we can write them with arrows overhead. So I can also write this as I with an arrow overhead, and I can do the same with j, write it with an arrow overhead. Both of these represent a vector. So when I'm going to write I, there is a dotted point, it's called the initial point, and then the arrow is called our terminal point. It tells us what direction we're going. So I, when I write it, we use we would write it as 1, 0, and we don't use parentheses, we use these they're kind of like brackets. And then j, it would be 0, 1. So they're kind of like coordinates, but we don't use parentheses to write them. So component form of a vector, it is the form you're most likely going to see a vector in. It's the ordered pair that describes the changes in the x and y values from the origin. So we like that initial point to be at the origin when we're writing our vector in component form. Now, if your vector does not have its initial point at the origin, there is a way to rewrite it so it is. And we are going to talk about that when we look at an example. So let's go ahead and practice writing vectors in component form. So in this first picture here, I have my vector u, and its initial point is at the origin. So when I go to write my vector, and I'm going to write it with the arrow because it's very hard to show bolded, I just have to figure out my x and y value. So my x value is at 1 and my y value is at -3. And that is going to be the component form of my vector because its initial point is at the origin. When we look at our second example here, so the vector v, its initial point is actually at 4, 4 and not the origin. So when I go to write the component form of our vector v, we're going to subtract our coordinates so that it will be moved to the origin. So the way I do that is you take the terminal point and you subtract the initial point. So the arrow end is called the terminal point. So I'm going to take the x value at the terminal point, -4, and subtract the x coordinate at my initial point, which is 4. And then I'm going to do the same thing for the y coordinates. So that's going to be -1 minus 4. So when I do that subtraction, -4 minus 4 is going to give me -8, and -1 minus 4 is going to give me -5. So that would mean I could redraw my vector with this initial point at the origin, and then if I could see enough of the graph, I could put the terminal point at -8, -5, and it would be the exact same vector. But this is the component form for v. Next, we want to talk about how to find the magnitude of a vector. So as I've already kind of stated, the magnitude of a vector is known as the length of a vector. And the way we denote, we're talking about the length of the vector. So the notation is kind of like an opposite value. It's these double brackets around your vector. So if you see the notation of the double brackets around your vector, you know you want to find its magnitude. So the formula for that, so given you have the vector AB, so it has to be in component form, that magnitude would then be found by doing the square root of a squared plus b squared. So you're squaring the x value and the y value and adding them and taking the square root. Right. The direction of a vector is then that angle. It tells us where to draw our vector on our coordinate plane. So it is the angle a vector forms with the positive x-axis. And it is very important here that we are talking about the positive x-axis. So in order to find the direction, so our formula for that, again, given your vector is AB in component form, the angle theta is found by doing tangent inverse of b over a. Now, our vector is not always going to be in quadrant 1, and this formula does not help us if our angle is not in quadrant 1. So the way we find that angle, so if we are in quadrant 1, we just use theta. It's tangent inverse of b over a. If we are in quadrants 2 or 3, the way we find the angle is we take theta, so whatever the tangent inverse of b over a is, and we add 180 degrees to it. And then if we are in quadrant 4, we're going to take our angle theta and we're going to add 360 degrees to it. So now we're going to do a couple examples where we find the magnitude and direction of our vectors. And the important thing here is that we have to be in component form first. So these are the exact same vectors as before. So our vector u, already in component form. So u equals 1, negative 3. So to find its, we're going to start with its magnitude. We're going to do the square root of a squared, so 1 squared, plus b squared, so negative 3 squared. So that's going to give us 1 plus 9, and then so we end up with the square root of 10. And I can't simplify that, so the magnitude of u is the square root of 10. So that segment or vector has a length of the square root of 10. Now, in order to find its direction, we are going to do tangent inverse of b, so negative 3 over a, which is 1. So you're going to use a calculator to find tangent inverse of negative 3 over 1. And you're going to want to make sure your calculator is in degree mode before you do this. So when I do tangent inverse of negative 3, we are going to get that theta is approximately negative 71.57. But remember, we have to pay attention to what quadrant we're in. And our vector is in quadrant 4. So what I want to do is I actually want to add 360 degrees to this. So in order to get theta, we're going to do negative 71.57, and we're going to add 360. So theta is actually going to be 288.43 degrees. Now, negative 71.57 degrees is what happens if we were to start on the positive x-axis and travel a negative direction. But we want to usually do the positive direction for angles. So the way we find that is to just add 360 to it to get the positive direction. So vector v, it's the same vector that we did previously. So we know component form for this vector is going to be negative 8, negative 5. So when I find the magnitude of our vector v, we want to do the square root of negative 8 squared plus negative 5 squared, which is going to be the square root of 64 plus 25. And we end up with the square root of 89. And that is the magnitude of our vector. Now we want to find its direction. So theta is going to equal the tangent inverse of b, negative 5, over a, which is negative 8. So using our calculator, we do tangent inverse of negative 5 divided by negative 8. And we are going to get 32.01 degrees. Now again, we have to figure out what quadrant we're in. And if I have negative x and negative y, I'm actually in quadrant 3. So we're going to take our 32.01 and we're going to add 180 degrees to it. So the direction is actually 212 degrees, 0.01, 212.01 degrees. So the last thing we have to talk about are scalar multiples of a vector. So remember, a scalar is just a number. So if we're going to do a scalar multiple of a vector, what we do is we multiply every value of the vector by the scalar. So whatever scalar we have, we just multiply x and y by that value, and that's how we multiply a vector by a scalar. So in our first example, given A, so here's that bolded way to write a vector. Our vector A is 3, 5. We want to know the vector in component form of 1/3 times A. So if I'm going to do 1/3 times A, I have to do 1/3 times 3, 5, which is going to become 1/3 times 3 and 1/3 times 5. So 1/3 times 3 is 1, and 1/3 times 5 is just going to be 5/3. So so 1/3 A is just 1, 5/3. Lastly, we want to find the magnitude of vector 3b if b equals 2i minus 5j. So the first thing I want to do is find 3b. So I have to do 3 times 2i minus 5j. So we're going to get 6i minus 15j. So remember from the front, I is the vector 1, 0, and j is the vector 0, 1. So if I'm going to write this as a vector, 6i would just be 6, 0, and then minus 15j, which would be 0, 15. And to write it as a single vector, it would just be 6, negative 15. We'll talk more about addition and subtraction of vectors later. So just I is the x, j is the y, and it's a negative. So now we want to go ahead. We have 3b as 6, negative 15 in component form. Now we want to find its magnitude. So the magnitude of 3b is the square root of 6 squared plus negative 15 squared. So we get the square root of 36 plus 225. And 36 plus 225 is going to be the square root of 261. So the magnitude of 3b is square root of 261. You can simplify that magnitude if you want, because 9 does go into 261. So if you wanted, you could write it as 3 square root 29. So the magnitude of 3b does also equal 3 square root 29.